Hi guys, welcome back. So what we're looking at today is 7.5 congruent triangles to the rescue. So let's go ahead and jump right in. So what we're looking at here first is transformations of lines connecting geometry and algebra. So for each set of lines, use the point on the line to determine which line is the image and which is the pre-image. Write image by the image line and pre-image by the original line. Then define the transformation that was used to create the image. Finally, find the equation for each line. So we've done something similar to this before. So looking at this, we have m prime and n prime. Because it's the primes, that means it's our image. So this is our pre-image. Now, what's the transformation? How do we get from down here up to here? Well, we translated up how many? Well, 1, 2, 3, 4. So we went up 4. Now, the equation for the pre-image, so we have a y-intercept at -2. And our slope looks to be up 1 over 1, 2, 3. So we have a positive 1/3 slope minus 2x. Now the equation for our image, once again, they're parallel, so y equals 1/3 x. And then our y-intercept is up here at +2, so +2. So you'll do the same thing for 2 and for 3. For 3, you're also going to answer questions 4 and 5 about this diagram, okay? All right, the next section. After working with these equations and seeing the transformations on the coordinate graph, it's good timing to consider similar work with tables. Match the table of values below with the proper function rule. So here in this first one, we're going from 16 to 14 to 12 to 10. We're going down by 2 each time. And we have the point, we've got these different points. So if we look, we've got -2, -2, -2, -2, -2. Well, that's not helpful. They're all going down by 2. So now we need to look for a given point. So this is the point 1, 8. Does this have the point 1, 8? No. But let's see. This one has the point 1, 8. So this one here is A. Now we're looking, here we have -1, so 1, 12. This one has 1, 12, so this would be B. So you're going to look for the given point, so 2, 8, -1, 8, -1, 10, to take and match these up, okay? All right, now the next part is looking at proofs. So we're going to do most of these together just because proofs can be rather complicated to understand. Prove is your key word for this lesson, prove. So in each problem below, there are some true statements listed. From these statements, a conjecture, or a guess, about what might be true has been made. Using the given statements and conjecture statement, create an argument that justifies the conjecture. So our conjecture is angle A is congruent to angle C. So we're saying this angle here and this angle here are congruent. What we know is point M is the midpoint of DB. So that means this right here and this right here are equal to each other. We know that angle ABD, so this angle, is congruent to angle BDC, so this angle down here. So those two angles are congruent. And we also know that side AB is congruent to side DC. So our justification here, so we know that AB is congruent to DC and angle ABD is congruent to angle BDC. Since BD is a shared side of triangle ABD and triangle, oops, that doesn't look like a triangle, and triangle CDB, these triangles are congruent by side angle side. angle A, and angle C are corresponding angles of congruent triangles, so they must be congruent. Now that's a lot. So a lot of stuff going on here, but we're using what we're given, and then if we can take and prove that we have three things congruent between the two triangles that were given, then we can say that the triangles are congruent. Once we know that two triangles are congruent, we know all parts of the triangle must be congruent. So yes, the conjecture is true, and here's our argument to prove we're right. Okay? All right. So we have two more proofs, just like before. So these are both yeses, so the conjecture is true in each case that we have here. Now, in this first one, it's telling us K, J, L, so this angle here, is congruent to K, J, M, so this one over here. So we're saying these two angles are the same. We also know that JL is congruent to JM. And what else do we know? They share this side, right? So this side is congruent to itself because it's the same side, it's just in both triangles. So we have a side, we have an angle, and we have a side. So we can prove they're congruent. JK is a shared side. So triangle KJM and triangle KJL are congruent by side angle side. And so we're saying JK bisects MKL. And so angle MKJ and is congruent to angle LKJ since they are corresponding. So by definition of bisector, JK bisects angle MKL. So we proved that the triangle is congruent. Then using that, we can say that these two angles are congruent. And then because this line is going through the middle, that means it is bisecting them. All right, so the last one I will leave for you guys to try out. Do your best. Think about what you know about triangles, what it's giving to you, what information you have to see if you can prove the triangles are congruent. So you're trying to prove that triangle ABM is congruent to triangle CDM. Okay? All right. The last part of this, why do we use a geometric compass when doing constructions in geometry? So a compass allows us to find congruent line segments because all radii of a circle are congruent. So this section here is diving back into looking at these constructions. So for this first one, create a rhombus. Make sure this one you're making a line that's parallel. Construct an equilateral triangle. And you can explain, I know without having a compass and rulers available to you, it's a little complicated, but you can explain instead of actually having to draw them out. You could take and explain how you would take and do it and what key features you would need to have. So like for the equilateral triangle, we can say construct a segment the same length as RS that is at a 60-degree angle from S. And then explain that we construct another one. So, and you can do a rough sketch of it by all means. I'm not going to penalize your drawings here. So then we'd have our equilateral triangle, just like so. A hexagon inside the circle, that means all your vertices are going to line up on the edge of the circle, okay? So be very careful with that one. And then bisecting, you know what that means. It cuts it perfectly in half. So explain these out and then give me rough sketches of what they look like, since I can't provide you with compasses for them and you don't have compasses. Okay? All right. Your keyword for this lesson is prove. Prove is your keyword for this lesson. If you guys have any questions, feel free to ask. Have a wonderful day.